and welcome to Learn Yourself. Today we are going to learn and understand about power. So the ability of lens to converge or diverge light ray depends on its focal length. Now what is the meaning of convergence and divergence of lens? That we have already learned, and that is when this is a convex lens. When parallel ray will fall on that, it will converge a light rays. So all the light rays, what all will fall on that, it will converge and all the rays will meet at one point. That will be the focus point. Now divergence means when a concave lens we are using and all the rays will diverge away like this. What all parallel rays are falling on the concave lens will diverge away. And how much they will diverge away or how much they will converge, that will depend on its focal length. The degree of convergence or divergence of a light rays achieved by a lens is expressed in terms of its power. So, in short, how much it can bend the light or how much it can converge or diverge a light, that is depending upon the power of the lens. So here convergence we can see it in convex lens and divergence we can see it in concave lens. But how much they are bending a light or how much this phenomena they can show us, that is depending upon the power. Now power is reciprocal of a focal length. So that P equals to 1 divided by F. So when we are taking a reciprocal of a focal length, we will get a power. Now let us understand more about the power and the units of the power. SI unit of power is dioptre and we are writing it with capital D. So D is dioptre and that is a unit of the power. Now one dioptre we can define it like the power of a lens whose focal length is 1 meter. It can be convex or it can be concave. If its focal length is 1 meter, then its power is 1 dioptre. So that is how we can define 1 dioptre of a power. So that also means that 1 capital D, that means 1 dioptre equals to 1 meter inverse. Now why this meter inverse is there? Because earlier we have seen that D equals to 1 divided by F. So F is in the denominator and that's why focal length will come in the denominator and that's why that is meter inverse. So 1 dioptre equals to 1 meter inverse. Now power of convex lens is always positive. So whenever we will say that plus 2 D power is there, that means that lens is a convex lens. And if the power of lens is negative, then it is a concave lens. Convex is the lens which is bending outward and concave is the lens which is bending inward. This is a convex lens and this is a concave lens. Now let us see one example that if the power is plus 2.0 D is there, then what will be the lens and what will be the focal length? So lens we can check from the positive or negative sign. If it is a positive, then it is convex. So lens is convex. And what will be the focal length of this convex lens? Then P equals to 1 divided by F. We can also write that F equals to 1 divided by P and that's why we will get 1 divided by 2. So when it is 1 divided by 2, we will get 0.5 meter. So this is our quotient. With quotient it is only meter and not the meter inverse. So our focal length is 0.5 meter. So the lens whose power is plus 2D, that lens is a convex lens and its focal length is 0.5 meter. So hope this video has cleared your doubt. In coming segment we are going to discuss many more important concepts. So don't forget to subscribe, Learn Yourself. I'll see you in next video. Till then, keep learning, keep sharing.